Hello everyone, myself Dr. Feroza Mirajkar, and today we will see a 8051 program to convert a given hexadecimal number to a BCD number, that is binary coded decimal number. The range of the hexadecimal number, it ranges from 00 to FF, that is these numbers lies from 00 and goes up to FF, and this is the table for the BCD numbers which are converted to hex. Okay, so here the BCD number ranges from 00 to 255 and the hex number ranges from 00 to FF. So this program will convert the given hexadecimal number to its equivalent BCD number. Here we will be using a formula: remainder is equal to dividend minus quotient into divisor. This is the formula to find out the remainder. So here the dividend is nothing but it is the number which you are dividing, that is representing the total amount to split. And what is the divisor? The divisor is the number by which you divide the dividend, okay, indicating how many parts to create. And the quotient is the whole number result of the division. So this is about the dividend, quotient and the divisor. We'll be using what these dividend, quotient and the divisor in the program, and also the remainder. So I will take FF as the hexadecimal number which is to be converted to the BCD number. So the BCD equivalent of FF is 255. So the logic of the program is you have to take the given hexadecimal number and you have to divide it by 0a, that is 10. So here I will take FF and I'll divide it by 0a, that is 10 in hexadecimal. So what you get here is, when we do the division, we'll be getting the quotient and the remainder. The quotient is 19 and the remainder is 0.5. So how we'll get this remainder? By using this formula, that is remainder is equal to dividend minus quotient into the divisor. So this is the first remainder. What is the first remainder? Dividend is FF minus quotient, what did we get? 19 into divisor is what? It is 0a. So when you solve this, you get 0.5, that is the remainder. So this is the first quotient and this is the first remainder after the first division is performed. Now we have to take the first quotient and again we have to divide it by 0a for the second division. So I'll take 19, that is the first quotient, and divide it by 0a. Again you get a quotient and the remainder. So the quotient will be 2 and the remainder is 5. So the remainder can be obtained by using this formula, that is 19 minus 2 into a. What is 19? 19 is nothing but the dividend minus 2. 2 is the quotient and into divisor is what? Divisor is a. So the remainder is 5. So this is the second quotient and this is the second remainder upon second division. Now we have got, that is we have taken the hexadecimal number, that is FF, whose equivalent is 255. But we didn't get the answer directly. Instead we got the digits, that is we got 02, then 05 and 05, which are required, that is 255. 255, it consists of the digits 2, 5, 5. So we got the digits of this BCD number, but these are not arranged. And as this is a 3-digit number, it cannot be stored at a single memory location. So it will be displayed in the memory locations as 02 and 55. 02 will be stored in one memory location and 55 will be stored in the another memory location. So from the digits 2, okay, from like we have the digits 2, 5, 5. 2 is ready, okay, that is we have 2. We can store 2 in one memory location. Now what about 255? So Here we have to take the other digits, that is 5 and 5, that is the first remainder and the second remainder, and we have to perform some operations on it. So what we'll do is here is we have to make this 5 and 5 as 55. So for that you have to take that is you can make it 55 by swapping the second remainder, okay, and that will be adding to the first remainder, okay. That is, here you have the second remainder and you have the first remainder, and here you have to make this 55 by combining. Now how we'll combine that? We'll combine that by swapping the second remainder and adding the result to the first remainder. So what we'll do here, we will swap this. We will swap 0, 5, that is the second remainder should be swapped, not the first remainder. When you swap this, you get 50. Now to this 50 you have to add the first remainder. Here we have taken the second remainder, okay, we have taken the second remainder, we have swapped it, we got 50. To this we are adding the first remainder, we got 55. Now this 55, it has to be stored into another memory location, okay. So what is the logic here? You have to take the hexadecimal number, divide it by 0a, you get the first quotient and the first remainder. Now take the first quotient, divide it by 0a, and you get the second quotient and the second remainder. Now you have to take the second remainder, you have to swap it, okay, you have to swap it. To that you have to add the first remainder. So here this second quotient, it will be stored directly into the memory location as you got the digit directly. Now here these two, that is we have performed certain operations on this, so that result we got it as 55, that will be stored in the another memory location, okay. Now we'll take a smaller number and we'll see what happens. Here I'll take 63, that is the hexadecimal number. So the equivalent BCD of this is 99. Take 63, divide it by 0a, that is 10. You get the quotient and the remainder, okay. Here the remainder is obtained again by using the formula remainder is equal to dividend minus quotient into divisor. So the first remainder will be 63 minus 9 into 0a, that is equal to 9. So this is the first quotient and this is the first remainder. Now again you have to perform the division on the first question, that is by taking the first quotient 09 by 0a. Here you will get the remainder quotient as 00 and the remainder as 09. So the second quotient is 00 and the second remainder is 09. Now how did you get the second remainder? It is dividend minus 0 into 0a, that is equal to 9. Now what you have to do? Already we have got one digit, that is one digit directly here, that is 00, okay. That is the first number, that is we have got it directly. So here this can be stored directly into the memory location. Now to get the second part, for that you have to take the second remainder, you have to swap it, that is 09 will be swapped, you will get 90. The digits of 09 will be swapped, you will get 90. Now to this 90 you have to add the first remainder, that is 09. So you will get 99. So you can store the result like this. That is, at one memory location you will be getting 00 and at another memory location you will be getting 99. So this is your result, okay. So here what we are doing, we are first performing the division operation, okay. Then we are storing the first question and the first remainder. Then we are going for a second division operation and we are storing the second quotient and second quotient. Then we are swapping the nibbles of the second remainder, okay. Then to that we are adding the first remainder and we get we store the final result, okay, and we'll halt the program by entering an infinite loop. So here we are performing two divisions, okay, to get the first quotient and first remainder from the first division, and second quotient and second remainder from the second division. Now we'll see the program. So here I'll explain the program by taking this example. So the first line of the program is org000h, that is the program starts at this address. Next is move instruction, move r0 comma hash 30h. So here we are considering the hexadecimal number ff, for which the answer should be 255. Now we will store this number at 30h location. Okay, so what we are doing is we are considering the hexadecimal number which is to be converted, and that is stored in the memory location 30h, and the decimal number after the conversion, it must be stored at 40h. Okay, so the decimal number after the conversion, it will be stored at 30h and 31h. Okay, now the pointer is initialized by moving the value using the immediate addressing, that is move r0 comma hash 30h. So now the number is it is stored in 30h, that is we are storing the number ff in 30h. So now this number ff, it has to be moved to the accumulator to perform the division. So the next instruction is move a comma at r0, that is here we are performing the division. Now accumulator is having the divisor. Okay, accumulator is having the divisor, and we need to look for the accumulator is having the dividend, and we need to look for the divisor. So the divisor must be moved into the B register, that is according to the requirement of the division instruction. Okay, so the divisor must be in the accumulator. Already the divisor is in the accumulator, that is ff. Now at the B register, you need to have the divisor, that is 0a. So what we'll do, we will write the next instruction, move b comma hash 0a h. Okay, that is we are moving 0a h to b. Now next we have to perform the division operation, that is divide ab. So after division, 19 will be the first quotient which will be in the accumulator, and the first remainder b, it will be in the the first remainder, that is 05, it will be in the b register. Okay, so we need to we need the first remainder. Yes, no, we need the first remainder which is needed to be added to the swapped number of the second remainder. So what we have to do is we have to store the first remainder into some another register. So we will store the first remainder in r1 register. For that we are using move r1 comma b. So the first remainder, that is 05, it is temporarily stored in r1 here. Now we will go for the second division. So to perform the second division, already 19, that is this is the first question, it is already in the accumulator, but the divisor, it is having the B register, it is having 5 in it. So we need 0a, that is 10 in that. So what we have to do is we have to again move 0a into B. Okay, so that is B register must have 10 in that to perform the division. So we will write move b comma hash 0a h. Okay, after that we'll perform the second division. Fine. So after performing the second division, the accumulator will have 02, that is the second quotient, and the b register will be having 05. Now this is not the final answer. We have got just the digits, that is 05, 02 and 05. We got the digits which are required for the answer, but it is not the final answer. So the final answer should be what? It should be 255. But this cannot be stored into the single memory location. So for that we have to store 255 as 02 and 55. We can store 02, that is the second quotient, directly into the memory location. So here I am using 30H as the memory location. So the content of the accumulator, that is second quotient, is currently in the accumulator. It has to be moved to 30H location. For that we will write the instruction move 30H comma A. That is, after performing the second division, we got the quotient which is in the accumulator. So accumulator value directly it is copied to 30H memory location. Now 30H contains the portion of the answer, that is 0, 2. Now to store the second part of the answer, that is 55. We have one part as 05 here at the first remainder and another part as 05 in the second remainder. So we want 55 to be written as 50 plus 5. Okay, so for that we have to take the second remainder, okay, and we have to swap it. So for that we will use swap A instruction. But swap A, it will work only with the accumulator, okay, but the second remainder, it is stored in B register, which has to be moved to the accumulator, and then we can use the swap instruction. So what we'll do is we will move, we'll use move A comma B. That is, we are moving the contents of B to A register. That is, the second remainder we are moving to A register, that is accumulator. Okay, once we have moved this remainder, that is 05 to the accumulator, then we will perform the swap instruction. So that is swap A. After swapping you get 50. Now to this 50, this first remainder should be added, which is stored temporarily in the register R1. So we'll use add A comma R1. So when you do this, when you perform this, you will get the result into the accumulator, that is 55. Okay. So now the result, that is addition of this 50 and 5, that is 55, it is presently in accumulator, that we have to move to the next memory location, that is 31H. So we'll use the next instruction move 31H comma A. When you do this 55, it will be stored at 31H memory location, and then we will halt the program. Okay, so here what we are doing, here we are loading the address 30H into the register R0. Then we are moving a value from 30H to accumulator. Then we are loading 10 into register B. Okay, then we are performing the division, that is divide A by B. After that we'll be storing the remainder into the register R1. Then again we'll load the register B with 10 in order to perform the second division. Then again we'll perform a division operation. Okay, after that we'll store the quotient at the 30H memory location. Okay, here then we are moving the remainder to the accumulator in order to perform the swap instruction. So we will swap it, that is, we'll change the higher nibble to lower nibble and the lower nibble to the higher nibble. After that we will use add instruction, that is add A comma R1. We are adding R1 to A, that is we are adding the swapped second remainder, that is 50, to the first remainder, that is 5. Okay, after that the result will be stored into the accumulator, which is next moved, or it is stored as a result in 31H, and we will halt the program. So input we are giving as FF at 30H location, and output we should get it as 02 at 30H memory location and 55 at 31H memory location. So we will see the execution of the program. That is, it has to be stored like this. At 30H you must have 02, at 31H you must have 55. So what we are doing here, we are giving the input at memory location 30H, and we are getting the output at memory location 30H and 31H. At 30H you should get 2, at 31H you should get 55. Okay, so now we will see the program, execution of the program. I'll copy this. We'll open the Keel software. Go to the project, click on new Mu Vision project. I'll use the previously used project, that is the Alice. I'll click on this and I'll save. As I'm using the previously used project, this window will pop up here. So I'll click on yes. Now search for the microchip device. So in microchip device, click on this plus symbol and search for 8089. Okay, 8089 C51. You have to search for 8089 C51. Click on OK and close. So here you have to click on no. Now go to the file, open new file. You can write your program here. You can type the program. I'll directly paste my program here. Now you have to save it. Okay. So here this is the hexadecimal to BCD. So I'll give the name as h2b.asm. Save. Now go to the target, click on the plus symbol and right click on the source group 1 and click on add existing files to group source group 1. Now search for your program. We have named the program as h2b.asm. Click on that. Click on add and close. Now you have to see whether your program has been added in the source group 1. Click on the plus symbol. So your program has been added here. Now we'll go to the project. Click on build target. Okay. So you can see here there are 0 warnings and 0 errors. Now go to debug. Click on start or stop debug session. Okay. Okay. Now I have to give the input at 30H memory location. So I will give the input as I colon 30H memory location. That is, we have to give input at this location. So at 30H, I will give the input as FF. Okay. Now we will run the program. So at 30H, you are getting the output as 2, and at 31H, you are getting the other part of the result, that is 55. So what is the equivalent of FF? BCD equivalent of FF, it is 255. So as 255 is a 3-digit number, you can't store directly at the one memory location. So what we have done, we have splitted it. So we are storing a part of the output at 30H, that is 02, and second part of the output at 31H, that is 55. Okay. Hope you have understood the program. Thank you.